Yeah, okay. Today's topic is no GIL and real gains. So yeah, it's quite a coincidence. My manager is GIL, so every time I talk no GIL, I feel a lot of offense. Uh, but yeah, it's little bit hardcore. So I try my best to explain it in some very plain language and help each other to know what is going on. So let me introduce myself. I'm Austin Wang. So Austin is some name I made up when I was in high school, and then use my Gmail and then GitHub. Then GitHub name become my name. So my passport name they nobody care. So I use that name everywhere. So it's made up. So no collision. So I'm currently the technical director of ClickHouse, and I'm the creator of CHDB. CHDB embedded version ClickHouse. So yeah, I think I need to stand here. Okay. CHDB is some open source project when I was working in Shopee, and before that I have my own startup, but I fucked it up. But when I was in some big tech and I did some open source project, it was some sort of success, and I got acquired by ClickHouse, so I am here. And I've been writing C and C++ for years, and mainly focused on system and data infrastructure. Speaking of GIL, so GIL is something like when we wrote Python, and we must handle the GIL and know what is the GIL. So GIL is some sort of global interpreter log. So with GIL, Python is some sort of single thread, not single thread, but you run only with one GPU core. Only one GPU core works. If you want to do something parallel and utilizing the whole GPU or a lot of GPU cores, yeah, you need to try very hard. So there's 13 years of attempts to killing the GIL. So there's only some very famous and notable tries. There's a lot of tries I didn't mention, and so the first try I think is happened in 1996. Yeah, that year I just go to my primary school. Then the first try failed. Then the 2007, the second try, and the 2016, the third try. Then we come to 2021. This is I don't know what's the time, but this is a try I'm currently talking, and this is the most promising try we can really eliminate the GIL. So maybe next year, maybe the year after next year, we will see something like Python will be real multi-thread language. So before starting, there are some rule made by Guido. Like if you want to make Python running without a GIL, if there's a hardline like you must make the single thread performance does not decrease, and then this is the bottom line, and then make it the multi-thread version you utilizing the a lot of cores. So every attempt died on the bar. So until one didn't. So here's I will introduce a little bit about each try. So when it's 1996 and Greg Steen, he introduced a free threading patch. So this patch is relatively simple, but there's still a lot of work. So he just break the one big lock into a lot of small lock on every multiple structure. So it was happening in Python 1.6, 1.4. Oh, at that time, I'm in primary school. I know nothing about Python. So this is the first try, but it makes the single thread version 2 times slower. So yeah, and I think this is a lot of people will not accept that. So still, the first time try got one survivor. There's a state named the py thread state. State is still in C Python today. So we will introduce more about that. And then it failed. And when it come to 2007, Adam Adam introduced another Python safe thread. This is a try using something like that. He tried to keep the object in the own thread. So if thread one using introduce some new object, and then thread one will take cover the its own objects by making the reference increase or decrease, and maybe destroy the object. If you want to use the object from thread 2, there are some mechanics like a monitor. So you need to introduce, let the Python interpreter know you want to use the object in another thread. It's a safe way, but you cannot you cannot do it very convenient. So you need to change your code to make it work. So even at that time, people are do not accept something like you put the work from the developer to our user. People will not accept that. So it failed again. So when it comes to 2016, Larry Hastings introduced something like he named it the GIL laboratory. GIL laboratory, it's a word from the surgical, like you cut off the GIL and make it work. And this time, from the performance side, it's even worse. So the performance decreased about 90 times on a 7-core CPU. So it's abandoned again. And so the core idea of that is we just make the object reference like atomic operation. Like if you want to using that object, you need to increase the object reference, and then if you get you don't use that, you need to call the Python decref. So every time when lot of threads are using one object very tense, it will be very slow, because every thread will trying to acquire the lock and trying to make it very tense to acquire make it automatic. So every time it's something like the good way to most scenario, but when it comes to something like computer heavy, it will not work. So when it comes to 2021, Sam grows, and he introduced a new fork. There's a non-GIL fork. He started work on 2001, still working on that, and this time it becomes a PEP. So I'm trying to make it simple. Like it's a little tricky. Like there's two counter. So one counter is kept on its own thread, and the other global counter. So when the own thread is referencing the object, it just increase the counter without acquiring the lock or something like that. It's a thread local variable. So if any other thread want to use that variable, it will acquire the lock and do it automatically. And also for some fast pass, like we always using something non and true as something like a number less than 100 and something like an empty string. The ref count is there's no ref count. It's kept in the memory and alive in the go through the lifetime of Python interpreter. So this is the current version we are working. So there's another version of Python now. There's a Python 3.14 T. T means free thread. So first time when the patch is introduced the first time, it's slower, about 40% of slower than the original global interpreter lock version. But when it comes to official, he kept optimizing that. So it's in the Python 3.14, it's about 5 to 10% slower. Still working on that. If you want to try that patch, you can use the Python 3.14 and just import this and print it's GIL enabled, and it will print something like a false. Yeah, so you will make sure there's no GIL run. So our ultimate goal is that make this version Python interpreter as a default version. So I will introduce more what is behind the curtain. So why it matters? So Python, we have been using Python for years, and there's a global interpreter lock, and the same. We did our work, and we survived. So this is very serious. So today we are building a lot of agents, like we are using Python as an agent builder, and some people are using Python for building some desktop apps, and also some servers and the data tools. Server data tools is what we are doing now. So agent builder is something like you will call some API and acquire some data, something like that. If there's still a global interpreter lock, it will be very hard to make it fast. So if anyone have ever tried to develop some desktop apps with Python, the user experience is terrifying. So there's an interpreter lock. So you must maintain the responsive UI very hard. So because if you are using Python to build some desktop UI, there's a global interpreter lock. So when it comes to something like a computer-heavy issue, the UI stop responding. Yeah, it's very terrible. And also, the server and the data tools. This is also important. I will explain that part later. And so, we are using we are dangling with the GIL for 20 years. So this is the full escape hatches we are currently doing. The first way how to deal with the GIL as a lib developer is something like we are doing in NumPy and SciPy. Like we just got the GIL released and then do everything in C and C++ and make it all the works with all cores and make it done and then return to the Python environment, and then it will work. This is was something done in NumPy, and still another way like what is TensorFlow and PyTorch doing, like they have some thread pool in C++. So every time there's some compute-heavy jobs, they just put the job into the thread pool of C++ and C. So like something like a CUDA, like something like you do some feature engineering. Yeah, that's how it works in TensorFlow and PyTorch. But either way, if we want to do something like parsing some variable across the Python thread and the C++ thread, there's some serialized and deserialized issue we need to handle. So a lot of libs like PyTorch data loader and job lib. They just introduce multi-processing, just fork a lot of Python interpreter and make utilizing the lot of cores. Another try is the first try is very tricky. So Python CYTHON. Yeah, this is not C. It's not C Python. Python doing something like they compile the Python backcode into something machine code and leaving the interpreter entirely. So it will work and utilizing the whole CPUs. So all these 4 hatches, just one rule: never touch the Python object from a thread. But yeah, if we need to touch the Python object, how can I do? So there's something like what we do and as a developer. So there's a gate. So if you want to do something like computer heavy and utilizing the CPU, you need to hold the GIL and let the Python thread stop, and you will do the jobs from the C++, C, and QDA, do all the works. But if you want to call something like a UDF, we are a database company, so there's a lot of customers want to write some UDF in Python. When we run the circle query, the UDF is called array row. So we cannot just do not care about the Python interpreter. So every time there's a UDF called, there's a GIL. So we cannot avoid that. And also some object type like PY object. So historically, pandas using string object for string column in pandas. So it's very slow for pandas processing large data set with a lot of strings. And also, if you want to do something like read a string and just write some string, you need to touch some API like a PY Unicode one by one. There's also a global interpreter lock. So if you want to use the Python thread-free version, there's some trap. So if you are using the thread-free version, you introduce or import one lib, just one lib. Do not support the non-GIL version of Python. The GIL will come back silently. So you are not using the GIL-free version if you using one lib do not support. So this is it's still very tricky. So what we do is something I can introduce. Yeah, it's something like that. You in thread A, you get you just introduce a new item like just create something like named L, and then in thread B, you just you use another use that object, but then drop it and clear it. So when thread A come to awake and he want to use the item, the object freed by thread B, it will be something like a crash. So with the Python GIL, it's not a problem because it runs as a single thread, so nothing will be touched. There's a lot of code like this we need to modify in every libs of Python. So we use some black magic for Python, the Python 3.14 free thread version. So the first is I introduce a little. The first is we just using two counter, one for the owner and then other for the guest threads. If you are want to use something like from other thread, you need to create the lock. And then there are some immutable objects like non-true, some number, and some small string. And also, when you come to use something like a dictionary or list, there's only one lock for the whole dictionary and the list. And And also there's some lock-free reads. Just you want to fetch something from a dictionary or fetch something from list. This is also no lock taken. So this is the black magic with Python 3.14 did and to keep it fast. So currently there are a lot of big library and redid its object prompting to adopt the new Python. So like NumPy, they just audit all the global C global calling and PyTorch. PyTorch is easy because it almost did everything in the C++. Do not even touch any object in Python. And TensorFlow do not adopt Python thread-free version, but yeah, it will work because yeah, everything in C++. And yeah, Kython and PyO3, the binding for Rust. For PyO3, it's easy because Rust has a lot of risk condition check and it's checked by the compiler. So what we will introduce is the CHDB, how we did this. There's until this month, it's July 2026, the top 316 compiled package in PyPy. There's a 61% of the libs has already adopted the Python free threaded views. So you can use almost 16% of the libs with the new Python version. But still, if you are using 100 lib, support the thread-free version, you introduce one lib, do not support, it will come back again. All the efforts in the 100 libs, it will gone. So yeah, still tricky. So like some famous libs like NumPy, Pandas, PyTorch, and CHDB, this is what I did, and we have supported. But for Polars and Protobuf and DuckDB, yeah, they do not support that. So if you are using these labs in Python thread-free version, it will ruin everything. So yeah, so what is CHDB? So CHDB is something we call it a rocket engine on bicycle. So typically, a lot of people here know what is ClickHouse, and a lot of users and in Russia and China and a lot of big companies are using ClickHouse as their data warehouse. And usually we will need a cluster and some big machine to run ClickHouse. But this is not a very the must-have thing. So we just transplant the ClickHouse engine into a small Python lib. So you can use the powerful engine inside your Python without install a server. So ClickHouse engine is something, it's a multi-threaded C++ engine. So we did a lot to about adopting the Python thread-free version. For ClickHouse, there's a lot of things maybe people do not know. Like we support 17 more formats in CHDB, and also, this is supported by ClickHouse. Like something like really crazy. You can put a lot of CSV into a zip file, and then put a zip file into some HTTP server. Then you can just run circle query upon the HTTP URL without ingesting the data. So it's something very interesting. And even more, you can do something like that. You can query Postgres table as a table inside ClickHouse without truly injecting the Postgres data to ClickHouse. So we just treat everything as a table. And we support a lot of things like, and also for Python area, we support zero copy read and write pandas and arrow. So it's something like you can using pandas and create some data frame. But when you want to describe the operation in circle, and you can just use CHDB and do some filtering on data manipulation with circle, and create a new Python data frame. And the data frame also, you can use pandas again, and there's no data copy. And also, yeah, we support Python UDF. So this is the hard part. So we used to be very hard. It's very hard to make the UDF work. So every time the C++ version want to call the function in Python, they must stop the word. So the whole threads are stopped and call the Python UDF. When it returns and the whole Python, C++ plus engine start running again. So there are 3 challenges that we made non-GIL pay off. Like we just moved Python UDF execution in process. So ClickHouse is running some Python UDF in a separate Python process. So every time you just run some circle query and processing like 100 or 1000 rows of data, it will call the Python UDF processing 1000 or 100 rows of data and return the result back and starting processing the data in batch. So and also, yeah, you need to declare it's a GIL independent margin, like you should declare it's a Python mode GIL not used. And also, yeah, when it's dropped to low levels, C Python string size is another hard problem. So after using the native in-process UDF, and we just you can declare some UDF like that. You just using the decorator and create a CHDB UDF like a I2 variable, and then when you call the UDF is in C++, is code something like that. You just passing all the arguments and call the function and insert into column. It will cost a lot of time to run the UDF because there's a GIL. So in the old version, we have to stop the word and make it like a run in one thread, like the red one. And then with the free thread version, we can use utilizing the all the threads. So this is it's very low level, and we should to declare it's there's no GIL used in our package, and then we need to trigger do some search, do some tests, like we need to trigger something like using the something like a none and run all the tests, but it crashed because every time we create a object like a none, the GIL is acquired if you are using something like a pandas none. Pandas none is named pandas NAT. So when you use that variable without very conscious, you just import pandas. There are some node will be created, and then if you are using something like a call it in other thread, it will crash. This is because this is a lazy initialized. So this is is a small problem. And also the hardest problem is something like that. We want to write Python string in CHDB multi-thread C++ engine. But when we're writing the Python string object, we cannot call the Python API. Because if we call the Python API, there's a GIL. So we must rewrite the whole thing processing the string with the C++ without touching the original API of Python. So it's very, very tricky. We struggle a lot on this part. But when it comes to the new Python version, it will all gone. And also the challenge comes from because pandas is the most used data processing libs in Python. But pandas has a real historical issue of processing string column. So if you want to create a column all by the data type is a string, there's a lot of objects, small objects created in memory. Make the memory fragment, and then you cannot run it very fast. Because if you want to just iterate the whole Python column, it will cause the memory jump to a like a jump list in the memory. So it's not very CPU friendly. But Python Pandas 3.1, I remember, 3.1 has introduced a third column using the arrow bucket. So at the arrow bucket string column, they use a whole bunch of memory. It's faster. So with adopting the new Pandas string column, it will be 10 times faster. And we broke a lot of things to try to make it work. And this is all we solved. Like the first time we just released the version, the non-GIL version, it will be slower, not faster, because the GIL is still introduced before we enter the C++ thread engine, because we need to find the variable and find the arguments passing by the user and make it, and then lock down the whole Python process, and then do the dirty jobs in the C++. So and also when it crash in Python, it will not crash but deadlock. So it makes it even harder to debug the problem. So so after some optimization, and we just tested on the new Python thread-free version with 16 threads, like it becomes about 3 times faster than the old version. So when does the non-GIL actually help? Because if you are using something like TensorFlow do not adopt the thread-free version, but because the TensorFlow has its very own data types and computer engine and all the things. But if your thread must execute some Python functions like UDF and the callbacks, this is the real gain from the Python thread-free version. And also, if you are processing some Python object, this is also the real gain. And when it doesn't gain the non-GIL version, if your C++ already released with GIL and doing the heavy lifting jobs like Pandas, like NumPy, like PyTorch, it will not be faster. And if you are using something like the different data types, like arrow, like NumPy, it will also not gain. And if your workload is a real single thread version, like some script for DevOps or something like that, you do not need to adopting the Python thread-free version. So it will be slower, not too much, but it will be slower. And if you want to try the Python thread-free version, you need to install a new Python interpreter named with a suffix t. So you can use UV Python and install a new version was thread-free, and then use that and install all the requirements you are using in your project. And then you can do some tests and make sure all the libs are working correctly. And then the tricky part is, you need to verify it's real non-GIL version, because if there's any lib do not support the GIL-free version, it will come back to there's still a GIL. So you can try it by yourself, and it's not very hard. Yeah, so you can do this and read some issue and posting on some social media. This will help the Python community to improve the thread-free version. I think, yeah, this time we have the best opportunity to really eliminate the GIL, which we have been doing for 30 years. And so there are three takeaways. So free threading reaches you through your dependency. So if you are using some lib, the lib depends on another lib, and they depend on another lib. There's one lib do not support the non-GIL version. The whole thing will go. Yeah, the GIL will come back, and you need to, if you want to use the non-GIL version, you need to restructure before you're parallelized. So there might be still some bugs people haven't discovered because there are not too much users are using this version. But if you try to immigrate your jobs to the thread-free version, it will help a lot. And also, the GIL was an amnesty. It's not a feature. So Python just removed the GIL. So there could be some bugs, but Python interpreter do not guarantee that. So you need to handle it by yourself, or handle it by the lib creator. You can read the issue to let them know there's some bug in this version. So this will help a lot. So you can, if you want to try CGB in the new Python thread-free version, you can just install CGB and run the test with the new interpreter. And you can find me anywhere on internet with the Oxen. So yeah, I think this is pretty much all I'm talking. Yeah. Thank you.
Thank you, Steve. Now we have time for your questions. So our assistant will go to everybody who wants to ask a question. And please wait until the microphone is used so that your question will be so,
Yeah, thank you for your talk. And I have a small question, not related to GIL, but related to CHDB. You said that it runs in a Python process, and I want to ask whether it supports multi-node or not. So if I have a cluster with multiple nodes, can I not host, but run CHDB here? Or it's planned somewhere, or it's already supported?
Yeah, currently the official version was HTTP. It's just an embedded version of host. So it runs in some small device, like you can run it on your Android device, Raspberry Pi, and your laptop. We do not support something like a cluster, but ClickHouse is a cluster.
Yeah.
So we just make some big things small. Comparing, maybe a lot of people know DuckDB. Yeah, DuckDB is doing something reversely. They create something small and trying to make it like a cluster. This is the harder way. So, yeah. But interesting, yesterday I just realized there's some guy just create a new project like a distribute CHDB. It's something like you just write pandas code. Because CHDB has a pandas compatible layer. You can just write pandas and then replacing the import pandas as PD with import CHDB data store as PD. Everything is done. The engine is changed. So there's some person did something, make it way more. Like you can write pandas and import CHDB replacing the PD, and then it will run distributedly in a Kubernetes cluster. And yeah, it's something like you can use pandas and make it a distributed database engine version of pandas. Yeah.
Yeah, thank you so much for your answer.
Thank you.
First of all, should I click on something? Or? First of all, thank you for a very interesting speech. I have a question. Like during my the working process, I had a case when I have big data frame, but it's not too big to use cluster, but still big for doing it locally, computing it, because it takes too long time. Can we call that this strategy could be quite useful for such cases when you have some data frame that not too big, but also not so small, like something in the middle?
Yeah, I have been talking in other PyCon and introducing the feature of you can just replace one line of your pandas code and using CHTB. And typically, we benchmark that it will be 5 times to 17 times faster when you just replace one line. Because as we all know, ClickHouse is some crazy engine. We have been optimizing every single line of code with the themed and the CPU instruction for almost 16 years. So we can do it very fast. So we can processing pandas data frame faster than pandas itself and more memory efficient. So you can just have a try. If not work, you can raise the issue and just talk to me.
Of course, thank you very much.
Thank you for presentation. I have a small question. How did using free-threaded Python affected your testing? Do you have new tests which test the parallel execution? Because with GIL, it looks like serial execution. So
yeah. So for the test case, I think for the thread-free version, we need to pass all the original tests. So every test, original test should not crash. But furthermore, we create a lot of new test cases, like introducing more complex Python UDF. So the Python UDF is called every time the C++ engine run to some rows need to process by the UDF. So we did a lot of tests with the UDF, and so currently it's working smoothly. But yeah, we cannot guarantee it is bug free. But yeah, for if you are trying to adopting the new Python thread-free version, you can just use the original test cases, because this is a very low-level works. So as a user of Python, it should be run without crash. But sometimes, yeah, there are some libs do not support Python thread-free version. It will introduce a GIL back, so it will not be faster. You can find out which lib is causing that, and maybe raise the issue to the lib maintainer. Yeah.
Thank you for the talk. So my question is about, as a person with more information on the topic, so do you think it's a matter of another Python version or two until we don't have the version with T and without T? So basically, do you think like Python version 3.15 or 16 is coming with the GIL-free mode built in already?
Yeah. For the thread-free version and the current 3.14, it's a new interpreter. So it's something like a fork of a Python interpreter. Why the Python community released two versions? Because there might be some potential bug, but it's slower when you run the new Python interpreter with a single thread usage. It will be 5 or 10% slower. But I think this work has been done from the Python 3.13. So mostly it will not crash your code or something like that. But still, it's not recommended to run the Python interpreter with a T in production. Yeah. I don't know yeah, if I understand your question correctly.
You think the process is irreversible? So basically, the next version of Python, like in 1 or 2 version, it's going to be only without GIL, or
Yeah,
that's
I think
basically the question.
I'm not a creator and maintainer of this Python, but as we can see, there's the top 316 libs. There's more than half libs has adopted the new fork. So I think the progress is very fast now. So I think hopefully we can use that version as a default Python version, maybe in Python 3.16. Yeah, this is only imagination. Yeah, I cannot promise something like that.
Yeah, thanks for the presentation. And just another question. So is there any supporting tool, let's say I can give my dependencies, so it can scan all my libraries or dependencies, so it can tell me, okay, this library is not supporting no GIL, so I can basically stop to going to production or something like that.
Yeah, basically it will be very simple. You just Python import that lib and just print its GIL war. I don't know. I can't remember the name. It's still work or something like that. You just do one line. You check. It's very easy to check the whole dependency. Like you can write a script and import all the libs in the requirements and check who is not supporting this.
And how is detecting it's supporting or not? So what is the detection logic itself? Because
if the lib has already support the non-GIL version, there's a flag. So the maintainer will add the flag.
okay,
Yeah.
okay, but still it can have some bugs. So it means like wrong porting. But at least like we are trying to support no GIL, so it's like there's a flag. It's detecting by this.
Yes.
Okay, great. Thanks a lot.
There might be some bugs.
Yeah.